Hey, what's going on, folks? It's Mike here, and welcome back to my Deep Programming Language series. In today's episode, we're going to be talking about something called a delegate. So with that said, let's go ahead and dive in on the Deep Programming Language website. And we're going to go to documentation, and we're going to go to the language reference, and then into functions here. Now, what I'm going to be talking about here, a delegate function, is related to function pointers. So I want to do a little bit of a review here just so you can see what the difference is, and then you'll know whether to use one feature or the other here. Okay, so I'm going to scroll down here, and you'll find function pointers, delegates, and closures here. So a few review topics for things that we've done in this D series, or again, if you're just jumping in, that'll be useful to know here. In the deep programming language, we can do things like this, where I create a local function here. I can do something like int a, b, and I can use this shortened syntax here to do something like a plus b, for instance, okay? And it'll infer that the return type is a integer based off of the arguments here. And this is the shortened lambda syntax form here, okay? So let's just go ahead and use this function here just so we can see what exactly it is here and that it works here. So 1 plus 2 here. And again, that's a nice way to write little functions here. So what's interesting here is if I look at the type of this, so if I do type of local here, and if I try to print this out, first and foremost, I'm probably going to get an error, right? We don't know, what this type of here is going to complain. So again, some of the introspective stuff, if you're not used to, do string of here, and that'll tell you the type here. This is telling us that this is this syntax basically here. What is local here? Well, local is a function pointer here. Takes in two arguments, int a and b, which we can see as well here. We don't really care about the implementation, right? We're just seeing what the type of local is here. Returns an int because, again, as I mentioned with this syntax form, it'll infer the return type. And the attributes with auto are also inferred. So there's no side effects, there's no exceptions, there's no garbage collection. So this is a safe function here, okay? All right, so that's just a little review here. But basically what we have here is something known as a function pointer. So what do we have? If I wanted to just declare something like this here, and you can see the syntax as follows here, is I could have this function pointer syntax here, and I'll call this a 2arg function, for instance. And then let's go ahead and down here do with our 2arg function, we'll point it to local. And then we'll do the same thing here with our 2arg function. Let's pass in 3 and 5. And, oops, let's see. I almost got it to work. For some reason, I always forget this. I don't know if it should or shouldn't do this, but I actually don't need to take the address here. If I'm initializing this, I think I need to take the address here, but this should work here. So anyways, let me make sure I save that, and we'll run this. And again, we can see that this function pointer here is otherwise, again, taking on the identity or the address of this local function, or really any function that I've defined here, right? I could have easily have just come up here and done subtract with int a, int b, and then return a minus b. And again, just to show you that the type signature matches, so I can still point this to subtract, and we should get, oops, if I make sure to now take the address here. Let me make sure I do that. There we go. Now we're okay here. Okay, so a little bit of playing around with the address and so on here, but I think you get the point here that, basically this function pointer here, which is our first topic before we get to delegates, is basically saying, hey, we can point to various functions, and of course, as long as we match the signature, well, just in the name, function pointer, point to a function, and then execute it and get the result here, okay? And this is the actual execution here when I put the parentheses here. Okay, so that's our function pointer review here, and a little review of some different syntax in our lambda functions here. Okay, so what I'm going to do here next is basically the exact same thing here, and I'm just going to create another function here. Let's just call this local function, for lack of a better term here. And I can use the function keyword if I want here, because I'm just going to define this over a few lines here. Let's just do int a and b like we've been doing here, and then I need to put a semicolon here, and let's just go ahead and we'll return a plus b here, and make sure to call this function here. So nothing totally new here. We'll just put 5 and 7 here, and get the result here. Now, what's going to be the difference here is, what if I have some outside variable here like function calls, and I want to count how many times I've called this function, okay? Now, the scope of local function and function calls, this variable, they're both within the main function here. So what if I try to do function calls plus plus, something like that here? Well, this is going to give me an error here, okay? And the error message that it's giving me is going to say, hey, we cannot access variable function calls in frame of function, okay? And that sort of makes sense if we look at this from a larger perspective here, because this is just like a function, right? We can, we have our function pointers, we have our regular functions like we defined here. And if I showed you in our subtract function that I tried to do function calls plus plus, you would also say, hey, that's crazy, right? This is in a totally different scope here. So I know I definitely can't do that because, right, this is defined and within main. This is one of the things we learn about when we learn about scopes when we first program. So this obviously wouldn't make sense to put in this variable function calls and subtract. Okay, so in D, even though this is sort of in the same scope as this function, this isn't allowed with function. Okay, so that's the basic idea here. So what we need to do here is this is where we introduce what is known as a delegate function. Okay, and delegate functions are actually going to be something that's quite common to us. Okay, so let's scroll down a little bit here and see delegates and closures. Okay, so delegate can be set to a non-static nested function. Okay, so let me just comment this out for now, since this isn't going to work here. I'm going to use this plus. I don't know if I've used this block comment, but it's kind of neat because then I can nest other comments here. But anyways, if you haven't seen that, that's the idea here. Okay, so now let's fix this local function here. And in fact, let's put all of this in here, and let's create what'll be a local delegate function. So local delegate here. And this time, instead, I'm going to use the keyword delegate. Again, you're going to see that it syntax highlights. And I'm going to make use of the function calls variable here. I'll do a plus b. Okay, we'll have it do the same thing. Make sure I put a semicolon to terminate this declaration here. And let's now try to call our local delegate function here. Let's use some numbers here, 6 and 7. And in fact, I'm going to comment out most everything here. Let's comment out the rest of these guys here, just so we don't get confused. All right. And let me make sure I keep this function calls. There we go. All right. So this works just fine here. Okay. And if I actually write out here the value of function calls, and maybe let's do a little printout just so you can see that this was actually incremented as such. It is indeed incremented to 1 here. And let's call this twice here just so we can see that it's called twice. So we are, in fact, able to update other local variables. Now, these are other variables that are within scope here. Okay, so again, let me show you on the code here. Function calls here, which is, well, just this variable here. As long as it's within the same scope here, now we can actually use these variables. They're within the same frame. Well, what's the frame? Well, it's wherever the main function is, for instance. Okay, so that's the idea there with a delegate. A delegate gives us access to the surroundings, so to speak here. And if you're familiar with C++ or other programming languages, you've probably seen these when we talk about the closure. Again, in C++, we do something like this, just in case you're coming from a C++ background, right, where you define your lambda function here. You have the brackets, and then you put the ampersand, your parameters, int A, int B, and then define your function here. Okay, you do something like this, auto local delegate equals, it looks something kind of like this. And this is the capture. And basically you can put in things within these brackets that are around the local delegate. Okay. So anyways, that's the idea. So if you understand that concept, that's the main important thing of this lesson here, that a delegate allows us to access other things that are within our sort of context or stack frame here. Okay. And just for completeness, let's go ahead and let's take a local delegate here. Let's do the type of. Here, I'll just change this declaration here. We'll use the same trick here with string of. Let's print this out. And you'll see that the type has changed here, right? It is now delegate here when we do delegate. Before, when we were taking the type of above here of a function, we saw that this would have been function. Okay, so there is a actual type difference here in the type system. Okay, now one or two other things to show here. Let's go through the documentation so you can see a similar example here where I can point this delegate to foo here. And foo, of course, we can see is referencing some variable outside of its scope. So again, this is assignable here, just like the function here. Okay, and in this section here, function pointers, delegates, and closures, here's just a little note here, note number 2 here. This combining of the environment, so that's the surrounding variables, and the function is called the dynamic closure. Okay, so if you see that word closure, that's kind of what it means. It's taking in some surroundings, and what I mean by surroundings is some other, say, local variables or other state and giving you access to it. Okay, so that's kind of the way to think of it. Now, there are some important notes here that I'm not going to get into as much here that the reference stacked variables that make up the closures are put on the GC, but there are some ways to avoid that. There's always ways to get around that, so no worries here. And that's just a little note that I want to make here. Now, we're not quite done here because I want to show you something else that will hopefully make this kind of come together here. But this is the idea of method delegates here, okay? So delegates to a non-static nested functions contain 2 pieces of data, the pointer to the stack frame and the lexically enclosing function called the context pointer and the address of the function. This is analogous to the struct or class non-static member function delegates consisting of a this pointer and the address of the member function. Both forms of delegate are indistinguishable and are the same type here. Okay, so delegates allow us to do something powerful. I mean, by having this delegate here, we can actually do some interesting things like point to member functions. Okay, but let's just go ahead and slowly walk into this topic here. And I'm going to go ahead and hide most of this that we don't need here. And let's go ahead and create a struct here. And it doesn't matter if we do this with a struct or class. I'm just going to call it creature, for instance. And let's say we have some properties like health. I don't know, maybe a function get health. And it'll maybe return the health and print a message or do something. But basically, we just have a struct here, and here is our member function. It's non-static, meaning, there's no static keyword in here. Okay, so that's important. And what this means is, let's go ahead and create our creature, C here, and let's do the function call, get health. Let's make the health something just so it's a value, I don't know, 50, something like that. Let's actually write out the line, there we go. Okay, just to make sure that this is working here. And we get 50. And let's keep all of this in the same window for you. And let's just do a little bit of investigation here. Let's go ahead and just see the type of, again, if I do creature.getHealth, and then we need to use that same trick, string of, so that we can actually print it out. Make sure that works here. Let's see, what did I get here? Type of creature get health. Okay. I gotta be a little bit careful here because I think that's just giving me the return type here. So again, let me get the actual information that I want here. That looks a little bit better. That's telling me the function type here. But again, let's go ahead and try to put together what we learned here. And instead of just the type here, right? This is just creature. What if I just put C here? So let's just put C, because that's an actual instance, right, of this creature here, okay? So let's see if there's a difference here. And in fact, there is. You see that? There's delegate, and then there's a function here. So delegate is here because, well, I mean, this is just a generic, like, let's point to, whatever a creature happens to be, and we'll get this function that returns an int. But delegate is an actual instance because it has context. And at the very least, we know when we're doing get health, we're doing it on a specific instance of an object. And that's the sort of hidden this pointer here. So again, where do we always have some context? Well, we have like a this keyword here, okay? And what are the things that are outside of get health? This function here that we have access to? Well, look, outside of our, brackets here, or excuse me, our curly braces, we have this, right? This, again, is outside of the function, but because it's a delegate, we have access to some outer scope. So again, hopefully that gives some idea of we've been using this feature of a delegate sort of this whole time, where in structs and classes, these are kind of the foundational idea here, where you get context of the data or the member variables, so to speak here, outside of the function here. Okay, and this is part of object-oriented programming, that you get a this, or again in languages like Python, a self dot type of function here that allow you to access your things that are within scope here. Okay, and now the final little piece here is, let's say then that I want to do something with specific instances of objects here, and I've got the type here, so I'll try to do this properly here. So if I create int delegate, and this is going to take in no arguments. So I wonder if I could just put in void here. We'll try it here. And let's just call this, I don't know, creature func or something. And let's point it to a specific instance here. C get health. And again, I'm going to probably mess up here. I want to be a little bit careful here. Actually, let me see if I do this properly here. I'm going to not, if I put the parentheses in here, I think it's going to call the function, right? So let's go ahead and see if that gives me a compile error. Right. Okay. So first things first, I can't put void in. Let's see. Let's remove that. And then this is indeed going to give you, right? This is trying to return some integer. So that doesn't make sense to assign it to a delegate. So again, you got to be a little bit careful. I know sometimes in D, we don't always have the parentheses, but what I'm really wanting to do here is assign it to this function here. And I think we're going to get one more mistake here. I think we're going to need the ampersand. Because again, it's trying to do the same thing, do the function call, right, with or without the parentheses. So we want to assign it to that function here, and now it'll work here. And now I could do right line from my delegate, and let's just call it creature func, okay? And put the parentheses to make sure I'm calling the function here, and we should see 50 again here. Because it's pointing to my delegate, a particular instance of an object here, and then we're calling that, okay? And maybe just to make this clear, let's just call this creature delegate. Just because, again, we want to be super specific. I like that naming just a little bit better here, okay? So hopefully that makes sense, folks. The main idea with delegates is it gives us access to variables that are within our environment, so within the correct context, or stack frame is sort of how I think about it. But in the case of object-oriented programming, you can sort of think about it like giving us access to the this pointer, which is part of the class here, so that you can actually assign to things like specific instances of objects. And then when you call that delegate on a specific instance of an object, then it will indeed call the function, get health on the specific creature that, again, it is pointing to. So it'll sort of do the right thing here. Okay, so hopefully that makes sense. We covered a lot in this lesson here. Some review, again, on function pointers, certain function syntax here, why functions are different, or function pointers, than delegates, and then again some of the inner workings of delegates. And it is worth a read otherwise of the documentation if you haven't seen it. Otherwise, as I scroll around here on the delegates here, just so again you understand all the inner workings. All right, so if you enjoyed this lesson and more, feel free to check out the rest of my D programming language lessons that you're watching right now here on courses.m.io. If you want, you can join the community forum here. We have lots of great discussions there. Feel free to chime in if you have any questions. Otherwise, I'll look forward to your comments and your discussion below. And yeah, let me know if you have any creative or interesting uses of delegates. Some nice exercises to try if you want to practice with these, or to try to make an array of delegates and have a function that calls a specific set of functions over and over again for some object that you pass in. So there's a lot of different fun that you can have with this, or have an array of delegates and then randomly call some functions, and maybe create some random behavior in a game. So again, a few ideas that you might have there. So anyways, folks, with that said, I'll go ahead and end this lesson, and thanks again for your time and attention.